Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. Today we have a Lexmark printer RCE, a vBulletin RCE, and a bunch of Facebook issues. So yeah, let's just jump into it. Before any of those topics, we have a bit of a research post by Lawrence Holtman on SSO gadgets. So yeah, not really a particular vulnerability in this one. It's a bit more of a research post, but I'll let Z get into more detail here.
Yeah, I mean, the annoying thing on this one is that they do call out and they're their real world examples, although their real world example, the one that's actually interesting at least, is they don't give us any information about the actual applications that had the vulnerability. It's just like, here are the vulns. So, I mean, it's questionably real world. They probably found it, but still, I mean, I'd have loved something that kind of placed it somewhere. What this thing lays out is what they're calling SSO gadgets, just ways of escalating from XSS, which is already a fairly powerful position to be in, to go from XSS to having account takeover. And that's through abusing the SSO system by trying to leak the access token or, the authorization token that comes through that you can use to then communicate with like the API or impersonate or pretend you are like that other user's account, log in on their account. So account takeover. The gadgets they lay out, none of them are like spectacular or anything that maybe if you sat down thought about you wouldn't actually come up with yourself. But nonetheless, it's always nice to have these posts that just lay it out, lay out the details. You don't have to think about it. They've laid out some of it for you. But again, they do have those assumptions with all of these. All of the gadgets covered here do assume that you have a victim that has or already has an active session with the identity provider. So it's like a Google OAuth SSO that you're abusing, or like a login with Google sort of thing. The victim user that you want to take over has to be logged in on Google already. It can't just be like a fresh account. They've already got to have gone through and granted consent. So kind of the same deal, logged in, and they've already authorized the application. And the support for prompt none authentication. Basically, that just means when you send somebody off to do the OAuth login or whatever, if they've already authorized the application, they're logged in, the identity provider just won't show anything. They'll just immediately redirect you back with the token, creating a fairly seamless login process where you just click the button and all of a sudden you're logged in on the actual application. So the first one, or their first gadget, is when implicit flow is supported. So implicit flow is basically like the weakest, still somewhat commonly seen flow where the code, so this is meant to be used in case like a mobile application or like a single page web app where it can't really keep any secrets. So instead of just, when they get the code back, it's in the URL and they get a code that is immediately useful that can be used against the identity provider's API to like get the account information, whatever, just immediately useful. So if you have XSS on an application, naturally you can just trigger the flow, the OAuth flow, wait for the page to redirect back and just read the token out of it. Kind of makes sense. You're sitting there on the application already. When it redirects back, you can read it. A little bit more tricky is when you come to their, what they refer to as the confidential clients, which are the code that comes back to the server. They get a token that needs to be exchanged yet. So token comes back to the server takes that token along with their own secret that the user can't see, takes both those values, sends them back to the identity provider, who then gives them the token, the actual authorization token or access token that can be used to access all of the victim's information. So it has to go through that extra process. Just capturing it isn't quite enough. You specifically need to prevent the server side from actually consuming that token. And for that, they end up tossing out kind of a couple ways of getting into that invalid state. One of those being just switching when you send the victim off to the identity provider using response mode fragments. So especially if the server side is going to process this, server side is going to look for a URL parameter. or containing the token. And when you use response mode fragment, you're basically telling the identity provider to respond not with the token in the URL as a parameter, but as part of the URL fragment, which is not sent to the server. So the server can't actually see it. Usually it would then be read by JavaScript, which would then do whatever, like sending it to the server or doing something on its own with it. So when it can't see it, you've gone through the proper flow, you've got that token, and your XSS, when you get redirected back, you'll still be able to access that. So you'll still be able to read that with your cross-site scripting attack, but the server won't. So the server won't have been able to consume that, invalidating it. So then the attacker can take the leaked code, and then in their own flow, basically replace whatever token they get back with that token. That won't work if there is another way of actually tricking the state there was also, or tricking the flow into kind of breaking or not consuming it, was by using an invalid state. That one you might have some mixed results on. I have seen a number of applications that just don't validate the state. Like they'll use it, they'll send it, and then they just don't actually care when it doesn't work. Other times, of course, it'll work just fine. And so with it, when you give it a bad state, it redirects back, sees the state isn't correct, and just doesn't consume the token again. Giving you a token you can then use and kind of inject into your own auth flow, allowing the attacker to log in as the victim's account. Because they have the valid token without actually having the session on the identity provider. Their last case is when you have a single page web application using a more secure flow and using PKC. Basically in this case, you just do everything that the server would do because you have, or not the server, sorry, the web app, it's a single page application. You have access on it. You can do whatever you need because you have access to all the information that the normal application would have. So why do these matter? I kind of like while I was kind of hating on it at the start of this, I kind of like the attack flow that they've got for using these, because it's turning a self-XSS into a account takeover through a chain here. They take the self-XSS and combining that with a login CSRF. So two vulnerabilities that two situations where basically in every application, law of bug bounties will not get paid out. Self-XSS is not usually considered a huge deal. Login CSRF, again, not a huge deal. Combining these two, though, like the login CSRF, that does give you an XSS against a victim. You log them into the attacker's account, then you can use XSS. Combining this with the takeover, you get that XSS running. Since they still have a session that's active on the identity provider, you can still kind of do the whole redirect flow for OAuth and have it do all of the redirects, and you can still get an auth token, still steal that token for their actual account, even though they're apparently logged in on the victim here. So it was nice to see kind of that chain. It is something worth being aware of, and just worth being aware of how you might be able to abuse the single sign-on implementations. The last thing that they call out here is just that Google single sign-on has kind of a broadly accessible SSO gadget. Basically, if you have a web application, so when you register for the Google's OAuth setup there, you register the type of application you have. Web apps are generally going to register as a web application. If you're a web application at the time this was written, the implicit flow just cannot be disabled. So even if your application were to be using a normal flow or a more secure flow, you could still just send in the request to do it as though it were an implicit flow and get that token back, gaining access to the victim account, again, with all of the same assumptions as before. So yeah, some interesting kind of information out of that. I think it'll be interesting to see how other people start chaining or maybe use some of this information in their own chains. Like I said, there's nothing really here that if you sat down and thought about, like, you probably wouldn't come up with on your own. But at the same time, having it all laid out here, having the background there, and all of that is nice to see.
I always like those downgrade type attacks, like where you would be able to change the flow to a weaker one, things like that. They're pretty fun in how they work. But yeah, I mean, a lot of this information seems like it would be useful if you find yourself in kind of a similar scenario. I think we might have covered a few of the tricks that are mentioned here, like in passing and in past posts. But yeah, I mean, like you said, it's nice to have it laid out. So yeah, but it's a bit of a long post, so there is a good bit to get through, especially if you're not super familiar with single sign on and all the common authentication flows there.
Yeah, he lays a lot of it out pretty nicely. About the only thing I'd say that isn't really laid out too nicely here is PKC and how that works, but it's not super relevant. Like, I mean, it's there, but yeah.
All right, so we'll get into our block of Facebook issues, of which we have 3 posts for, all of which are by Yusuf Samuda, who we've covered before for these Facebook issues. So yeah, this first one is the easiest one. It's an account takeover of Facebook accounts via Oculus VR due to a token leakage in the meta auth process, which was introduced in kind of an interesting change when Oculus switched from using Facebook accounts to using meta accounts. To be honest, I didn't even realize they switched the account types, but it seems they changed it to be more interconnected, I guess, with Meta and Facebook and whatever trying to buy in wholesale into the metaverse idea. But yeah, so the authentication flow for Oculus was changed to use meta accounts, and when they migrated over, they state that the redirect URL previously for the auth flow was protected against any token leakage as the redirects were made through JavaScript. They don't really elaborate. I believe that's just because the redirection and the routing was internal, so you didn't really have much control over it as an attacker. But anyway, after the migration over to the new meta auth flow, it would redirect directly via URL, and it was now possible to leak the token uh, as long as you. Well, so okay, you could redirect to any subdomain of Oculus. You couldn't redirect to like an arbitrary, attacker-controlled URL. But on Oculus, you have like the forums subdomain sitting and others, which would redirect to third-party apps. So by chaining an open redirect in any of those with this issue, an attacker could leak a first-party token and hijack the account. Now they did like full chain and exploit for this, but they don't go into specifics on the open redirect in the post because it's not actually fixed yet. So yeah, they just couldn't really go into detail on that.
Are you telling me they didn't have a endpoint called /open redirect?
I know it's hard to believe, right? Yeah, so maybe we'll get something on that in the future, but yeah, it's just kind of treated as like a magic, like we had an open redirect and that's how it worked. Even though it was a fairly simple issue, it paid out pretty big. This netted like a $44,000 bounty from Meta. And yeah, the other issues weren't really small payouts either. So,
I mean, as easy as the issue is, like, it is an account takeover. It is giving, for anybody that's at least authorized the application, they are getting the first party token, which can be used for a lot out of that.
Yeah,
like very useful. So like the payout makes sense for account takeover.
definitely. So we'll jump into our next Facebook issue here, which is a DOM-based XSS reachable via instant games, which I believe is like Facebook's arcade functionality. And again, this issue is fairly simple compared to a lot of the Facebook bugs we've covered in the past. The bug is in this Go URI on window function that we have up for those who can see the stream, which is used for supplying the window location and directing there for the game. And it's also responsible for verifying the URL that's passed in. But what's kind of interesting is that the function will take multiple types of input. It'll try to accept both a string as well as a URI object. So strings are validated against, a whitelist before creating an internal URI object instance. And URI objects are just passed through with the idea that, URI objects are only going to be able to be created by like trusted sources. The problem is, though, they never actually validate that the object being passed in is a URI object. So if an attacker passes in basically any type of JavaScript object, like let's say just an array, you could bypass the validation, it would just pass through. So it was kind of a gaping hole. Again, one of those situations where the function was trying to do too much. It was trying to allow different types of input, and then just one of them was not really validated at all, because they incorrectly assumed it would always be this trusted URI object instance. So yeah, there's actually multiple places where this bug kind of happens and is reachable. Basically, anywhere that would use Go URI on window with user provided input without converting it to an internal URI object first. And in this case, there were two modules that were hittable from an attacker, which were handlers for cross-window messaging between the host and the iframe for the game. Being use interactive plugin SDK message handlers, open URL async method, as well as the Instinct Games open external link dialog, show generic dialog method. The first method I mentioned was only really hittable from a few games. The second one is presumably hittable by more, but it requires an additional click to exploit because, it's it's for an external link dialog, so the victim would have to go through an additional click for the exploit to work. That said, later on, Yusuf goes on to detail that Meta confirmed this happened in other places of Facebook as well that didn't require any user interaction, so there were other places where it was a bit more serious in that respect. Bounty in this situation was a little bit interesting. Yusuf claims it should have been like around 60K according to their payout rules, with like a 50K base, though he only got paid 28K. So he mentions he raised this concern and hoped it gets corrected. I thought I'd call that out though, just because I think it's the first time I've really seen a dispute, I guess, around Facebook's bounty payout. And that is like a fairly big disparity. You're talking about like half of what he was expecting. But yeah, I don't know. Possible that gets resolved or whatever. I'd be curious to know like why Meta didn't want to pay out what, like the 50K base or whatever. But yeah, as per usual, we don't really have a lot of the details on that, especially with Facebook. We don't really have much from their side of the fence when we cover them, so
It could
it's hard to
just
really
be
speculate.
it could just be in terms of like when they're calculating it, somebody just legitimately made a mistake. Just looking at the payouts there, they do have like the 2-click has a 25,000 base versus 1-click being a 50,000 base. Could just be like a legitimate mistake on that sort of front. Like miscategorizing it or whatever. It sounds like from what he says there. I already closed the tab. There we go. What he says there at the end, I raised this and it should be corrected. Sounds like they are just correcting it. Like, it doesn't sound like he's really needing to dispute it, just pointed out the mistake and, got it. Not like a fight, although we don't have the details there. Sounds like Facebook's kind of acting fairly in this case.
Yeah. Okay, I read that a little bit differently, to be honest. I read that it should be corrected as like they should be like,
Uh,
I hope they fix it kind of
I
thing.
see
But
how, yeah, I definitely read that a bit more charitably, as in it's going to be corrected and like indicating that it will be to us, but I could see your reading too now that you say it.
yeah. But bounty stuff aside, pretty cool bug, and like I said, it's just another instance of trying to do too much and supporting too many things in one function and just not validating assumptions properly on one of them. So there is one more Facebook post. This last bug was again in the game subsystem of Facebook, this time in Canvas on Comet games, which I believe are a newer thing. Unfortunately, there's not really a lot of public information about them, so I wanted to go into a bit more background on that, but I can't really. But yeah, I'll let Z jump into this one.
Yeah, and there's kind of a bit to dig into on this one. One of the important things is understanding kind of the existence of the arbiter endpoint. And that's something the last time we covered some Facebook bugs or Facebook auth issues was back in Facebook Games, September of 2021 on episode 79. I believe it was a few more bugs from Yusuf again, so basically he just keeps hitting them. So if you want kind of more details, I think I go kind of deeper on like the arbiter and stuff there. Um, Although for our cases today, what kind of matters is that when Facebook kind of embeds the applications within like their website or one of their sites, which presumably Canvas on Comet does, like some attacker controlled data, what they'll do is you'll be able to they'll have some sort of interface that you can call through and goes by different names. Compat's one we'll be talking about for this bug, but in general, what ends up happening is they kind of proxy some of the OAuth requests and responses. You'll communicate, in this case, with Compat, who will then open the OAuth request Facebook. You can see the link if you've got the stream open or video open. And it uses this redirect URI. You'll notice it goes to dialog or like to facebook.com dialog return arbiter. That's kind of the key thing here is that arbiter's in use, and then because it's basically embedding this on like the attacker's page embeds Facebook, which embeds the arbiter. So then the arbiter will get the response back, hands it off to Facebook, who then decides if they should actually give it to the application or not that made the original request. So by proxying it, this also ends up meaning that a lot of first-party Facebook applications are going to accept this dialog return arbiter endpoint as a valid redirect URI, which can then potentially, if there are some bugs, can potentially end up leaking that somewhere it shouldn't. So that's kind of what arbiter is. It's proxying OAuth stuff and the access token. There's a little bit more to it, but that's the gist of it. So then when it comes to this bug, you've got this Compat system, and Compat, the way it's supposed to be used is, Canvas on Comet. Spectre said, we don't really have a lot of information on what that is. I tried looking for it briefly, but I didn't want to dig in too far. But effectively, that will open up an iframe to apps Facebook Compat. From there, it'll do some validation, validate the origin, whoever's opening the frame, and does that validation and establishes a communication channel. One of these message channels. Establishes that, and then once that's established, it basically just trusts the origin. Any message that's sent, so if you send it the message to open up a dialogue to whatever Facebook app, the OAuth flow for whatever app ID, it'll just do it. It doesn't do any checks because it's expecting whoever opened Compat, which is on the Facebook domain, it's doing that same, or it's checking the origin of it to make sure it's from Facebook. It's assuming they're going to do the security in terms of how they deliver that, making sure an application doesn't request an auth token for an application that isn't their own and all of that. And those bugs we talked about back on episode 79, those were dealing with that layer of authentication checks and bypassing them, if I remember correctly. So this one kind of takes place with that, with the origin checking inside of Compat. What Compat does when it gets the origin here, we've got the code here, basically just pulls out, gets the URI, pulls out the actual iframe origin, compares are they the same origin. So it knows that it's on, the Facebook domain, wherever it's hosted, knows its own, make sure they're in the same origin. Kind of makes sense until you go and look into this is same origin function itself, or method, sorry. And what it does, at a glance, this looks okay. It grabs, so it's expecting the URI objects. So it grabs the protocol, make sure there's a value for the protocol. If there is a value and get protocol is not equal to get protocol, then it returns false, and basically it does that for the domain, the port, the protocol. For all three of those, it just checks to make sure, the one grabbed matches what it's, or matches the current domain, or that page's origin. The problem here is when you're able to get unexpected values through this. So if you were to open the Compat frame inside of a sandbox iframe, what ends up happening is that this URI object that ends up resolving ends up having a lot of these properties like get protocol, get domain, get port. Those are going to resolve to null, which means in this check, if get protocol and get protocol are not equal to this, because of that and there, it's going to hit this condition, have a null value, which is false, or well, resolves kind of down to a false. We'll say, hey, this is false, not even do the rest of the check and just skip this if condition. So it's not going to return false for the protocol. It's not going to return false for the domain, and it's not going to return false for the port because it's skipping out of all of those checks early on. So then you're left with just that last check, which in theory should be the null check. Does this toString triple equals? And to be clear, for those of you listening, the not equals from before, that's doing a double equal sign and not sign. So it's not going to be doing, or not going to have any of like the type coercion issues. Anyway, for the string one though, that should be, or you can kind of read that as null check. But what actually happens when you have the URL or URI object with all of these nulls is it becomes the literal string containing the letters NULL rather than an empty string. So this check just doesn't work, at least for that case. Meaning, if you open Compat in a sandbox iframe, it's going to get past this origin check and it'll be trusted by Compat as though it's from a trusted source, which I think is just a really cool bug because reading this code, it's not immediately obvious that there's an issue. Of course, you do need a little bit of context from what it's grabbing, and this is all minified JavaScript, so it's a bit of a pain to read. But as a bug, I think that's really cool. And once they get through that, the post goes into kind of crafting the exploit, needing a little bit more information for like proper states, since it works with callbacks, and dealing with some of that. But the core bug, the core vulnerability is this origin check bypass to basically be trusted by Compat and be able to open a dialog to get an OAuth token for a first-party application. And once again, leading with a like $62,000 bounty.
Yeah, it's a really cool bug and reinforces that handling types in JavaScript is difficult, or dealing with them correctly. So, yeah, like you mentioned, $62,000 bounty. So all in all, I believe this led to like $114,000 in bounties or something like that. I don't have the exact number written down here, but yeah, there was a lot of bounties paid out for this, but that's not overly surprising. Facebook is generally pretty good in that respect. So, yeah, definitely rewarded all the research efforts of the researcher here.
Yeah, and these are
as per usual.
Looks like he had effectively like one a month. The first one reported, I guess, a little bit more than one or less than one a month, but very late August, and then October, end of October, and end of November for the bugs. So just a few months of work. Well, I mean, I don't know how long he was actually searching, especially on the first one, but I mean, and I should also preface that by saying, a few months of work, but he's clearly been working on Facebook for a while, since I believe we were covering posts of him doing some pretty crazy stuff against Facebook setup, more than a year ago. So
yeah,
some good finds, but he's definitely spent a lot more time understanding Facebook.
Yeah, that said, a lot of these vulnerabilities that were covered seem to be a newer like functionality, which makes sense then which makes sense why it's like, a bit weaker in some respects than some of the other Facebook issues we've covered. All right,
it's a bit weaker, but you really have to dig in to kind of understand some of the JavaScript and get into it, because this isn't exposed in like nice clean source view. This is deep down in like that minified JavaScript, where it's like, oh, and then this JavaScript just doesn't quite do this right, and where you can go from that.
Something a lot of people don't want to look into, let's say.
Yeah.
Don't want to bother with. All right, so last week we had a MyBB vulnerability, and this week we have a vBulletin vulnerability, so it's kind of funny how that worked out. Yeah, and I'll let Z jump into this one as well.
Yeah, and this one kind of surprised me a little bit, just in terms of what vBulletin does, but effectively the issue is deserialization, which oftentimes we don't tend to cover too much because they don't tend to be that interesting. And indeed here, like, the actual vulnerable post request. They've got this Ajax API user save endpoint. Search prefs takes in a string to be deserialized. Now, the thing with PHP is that any sort of serialization attack has to take into account what libraries or classes are actually available in that application. There is no like universal gadget against PHP. A language like Ruby has universal gadgets. So you're somewhat limited in terms of what you can do depending on the application itself. And what vBulletin does is they actually use these traits inside PHP. This trait no serialize, which just hooks the wake up and unserialized functions to throw exceptions. So basically saying any of the classes inside of vBulletin, or they say virtually every, so there's probably some, but some that aren't, but any that would actually do anything of interest specifically cannot be woken up or unserialized. Which are two of the functions that are the magic functions, which are called when you unserialize or like try and instantiate the new object from a serialized state. So I didn't even know you could do that in PHP, to be honest. That I think that's newer than from when I used to work in like the PHP 5 days. Nonetheless, it's interesting to see them doing that because that takes away a lot of the attack scenario. But what they were able to kind of take advantage of here was PHP's auto-loading. And auto-loading is a really awesome feature when it comes to development because when the PHP engine runs into like a class, it's never seen this, doesn't know where it's from, rather than just tossing an error, you can actually write code to be called whenever that happens and be like, hey, I know where that's from, and include the file, usually based off of whatever the class that's trying to be loaded, like whatever it's named. It'll try and figure out what the file name should be from that and try and load it. So it can kind of provide some really interesting or powerful primitives, but you kind of need that access to actually be able to craft an arbitrary class name, which is something you get out of deserialization hacks. You are able to specify the class name that you're deserializing. So what they were able to do was they were able to use that. And I guess I should mention actually within the vBulletin code base, there was a monologue. They did have that class kind of deep within some of the vendors' files. That class did exist, and that one does have a deserialization gadget that can be used, but it wasn't loaded. That kind of matters because the way they actually went over the attack here was using the autoloader to trick it into loading the Google login vendor autoload, which would then load the monologue so they can then have their actual serialization. So I thought that little trick of abusing the autoloader to actually try and get something off this was a fun little trick, something to keep in mind if you do run into the PHP deserialization issues and trying to find something. Taking a look at the autoloads, I think that's something that can easily be overlooked. So I at least wanted to call it out here. I thought it was really cool to see this kind of chain being done here. Ultimately, the vulnerability is pretty simple, but I think that trick is worth noting.
Yeah. Yeah, so that effectively gives an attacker like a pre-auth deserialization bug in the registration process, which sounds like super useful, though the title kind of suggests that exploitation was a little difficult there, because yeah, like they couldn't use the gadgets from vBulletin's classes, like Z said. They also tried to generate payloads for dependency libraries using PHP GCC, which they thought they might be in luck for with vBulletin because they use monologue. But as it turns out, even though the lib was physically present in the source, it was unreachable as it's used for like Google login, which is disabled by default. So the way they took advantage of this, I thought was kind of interesting, and I figured I'd give it a quick call out. They basically use the auto loading to like construct the path to the monologue library to load it, because yeah, then they were able to get it loaded, and then they were able to utilize the PHP GGC gadget to target the monologue. And yeah, it was kind of a cool exploit chain how they took advantage of it. All right, so we'll get into our last topic here, which was a printer RCE in the Lexmark MC3224 printers. leveraging some high-level vulns in the firmware. There were 4 vulnerabilities involved here specifically, starting out with a file upload primitive, and a pretty basic one at that. By simply sending a post request to this upload file import fax logo endpoint, you could upload arbitrary file data. Seems there was no like validation or checking to ensure that it was actually a logo, so you could just get arbitrary file contents on the system there. From there, they detail an SSRF they found on the WS Print SOAP web service. Again, somewhat simple one. The WS eventing notify to address had no validation, and so you could make a callback direct to an endpoint on the printer itself. So, fairly straightforward SSRF there. Next up that they detail was a file copy primitive on the debugging daemon, which normally wasn't accessible. So, it's a bit questionable, I guess, to even call it a bug. It's probably more just like a legitimate functionality that's not meant to be exposed. But because of the SSRF, they were able to chain to hit it. The debugging daemon was also a fairly simple line-based protocol. And yeah, so one of the commands it accepted was the ability to copy files under the fax user. The final bug they had was a privesc in the auto firmware debug daemon, which would start as like a systemd service. There they create and listen on a FIFO pipe for commands, and crucially that FIFO pipe is writable by anyone. It's got like 0666 permissions. So yeah, and again, it would take commands by scanning for semicolon characters from that pipe, and it was vulnerable to command injection. So by chaining it all together, they could use the file upload to get a privesc payload uploaded, use the SSRF to hit the debug daemon to copy that payload into the pipe, which would then trigger the command injection to get root. So very simple issues on their own, but the way they were chained together was a bit interesting, I thought. The time to exploit I thought was also a little bit interesting, because they say it takes about 100 seconds on average to exploit, and that's just because of the how much processing has to be done by that auto firmware debug daemon. Yeah, it's just kind of interesting to see the exploit taking that long, but it does kind of make sense when you consider how simple and line based their parsing is like that.
You don't expect the printer to be terribly high
No,
performance.
you
But
don't
yeah,
expect it to be a powerhouse.
it's definitely kind of interesting to see, because these initial primitives that they had, like that file upload primitive, it's like you can write a single file. They don't have it's not a directory traversal or something. It's a single file that you can write. You can write whatever you want to it, but it's still just that single file. Not a very useful primitive at all. And, when it comes to the SSRF, usually, granted, printers, you're going to be looking at some different things like these internal services, but oftentimes, you see that more as the cloud. You get access to some of the cloud information through the metadata service or something. So just taking it a different way. Yeah, nice chain.
Yeah, nice simple chain to end it off. So yeah, unless you have any last minute thoughts, see, we'll go ahead and wrap up the episode.
Yeah, no shout outs.
All right. And just a quick thing from chat, I wonder how scanners compare. Yeah, it's kind of an interesting question, because we've covered printers a fair bit on the podcast, but scanners not so much. I'm because a lot of printers have scanners built into them too, so I guess they're kind of one and the same in a lot of cases. But yeah, don't really see too many vulnerabilities or exploits targeting scanners. So that's kind of an interesting point I hadn't really thought of before.
I feel like
yeah.
part of that probably just comes down to the fact that corporations are buying those all-in-one machines. This is one of those all-in-one machines that can print, can scan, can fax, can do all of that, rather than just a standalone printer.
Yeah, it's kind of just bundled all together.
Yeah, I haven't really looked for it, but I feel like I haven't seen a standalone printer in quite a while, outside of one of those little handheld receipt scanners. And even then, not networked usually that I've seen. When I have seen them, they've been old USB things. That could just be my experience on that, but I feel like printers are more likely to kind of have a lot of random features and just be installed in. IBR mentions in chat. I mean, everyone has a scanner's part, so I'm guessing you're talking about phones or whatever there. As for Circane asked a question there, what does printer RC even get you? Leaking documents? Oftentimes printers are networked, They're in a corporate network. So it's a escalation point. It's like your foothold that you can then pivot or go further into the network from, especially because it's intended to be accessed by all of those desktop machines that the employees might be using and such. So yeah, there's the things you can do on the printer, but it's also just a spot to launch further attacks to get deeper into a network.
It's pretty difficult to isolate it off, yeah. All right, so yeah, with those questions aside, that's everything that we have for today. So thank you everyone who tuned in. The VOD will be up on Twitch immediately or on other platforms like YouTube tomorrow. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. And with that said, we'll be back tomorrow for the binary episode. That'll be at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.